Good morning, and thank you for attending this morning for this keynote. My name is Laurent Jaffart. I work for ESA since the 15th of May. I come from industry, spent 22 years working for Airbus. I spent 10 years in defense, 1 year in Washington, D.C., 11 years in space. And it's a pleasure for me today to talk about the future of security in space communication. What are the challenges, the opportunity, especially in the concept of software-defined space, software-defined satellites, and the ability to evolve in generations of what we put in orbit. So the agenda I will follow is basically the following: looking at the need of the space infrastructure, looking at threats, vulnerabilities, looking at emerging trends, technologies and challenges in space security, what is the ESA response, the role of industry and academia in securing space communication, and I'll try to bring a conclusion. So, space is considered as a critical infrastructure, providing fundamental services to European citizens, but in fact to citizens of the world. And this includes global communication. And the need for communication has been there for a while, since the beginning of civilization, in fact. And space communication is key for defense, surveillance, but also transportation applications. The threat landscape is evolving rapidly, and we see that the telecommunication is a backbone for industries. It's the backbone of how we interact together as citizens of a country, as citizens of a continent, as citizens of the planet. So, why space-based secure communication? Today, we are seeing communication as ubiquitous. We are seeing additional resilience to the terrestrial communication with space networks. And we're looking at added value services, for example, quantum key distributions, where through the telecommunication network, we'll be able to distribute the keys in a new fashion, especially in the post-quantum processing world. But it's also important to look at communication in the frame of disaster recovery or emergency situations. So ESA is playing a pivotal role in developing critical space infrastructure. We are working together with the European Commission on the program called IRIS². We are also working on other flagship programs of the Commission, such as Galileo for navigation, Copernicus, but also for meteorology. The disruption of operations of this mission can affect everyday's life for the citizens. The day you're not able to communicate back home, your family will get worried. The day you're not able to communicate with your colleagues, you're getting inefficient. So preventing disruptions is going to be key and is a priority for us at ESA. So we need to look at how we can secure those networks, but also how we can secure the data going through those networks, which are inherently vulnerable. So there are threats, cyber attack. I think you know very well this context in Estonia. The threats could come from state actors, could come from cyber criminals, but the list is endless. The vulnerabilities which are being exploited are around the communication protocol, the authentication, and let's face it, the human factor. How many times do you hear people clicking on a phishing link? But that leads to risk that we have not yet seen materializing in orbit, but the threat is high, to potentially see hijacking a satellite. The potential impact is a loss of critical infrastructure. This is why redundancy is important. This is why the concept of disaggregation of communication that the US DoD is pushing is adopted with constellation needs like RA². But what we see is we need to look at it from an end-to-end perspective. We cannot isolate only the space segment or the ground segment. We need to look at it from the entire end-to-end network. So the threats that we're seeing are known, but it's crucial to understand that the systems are becoming more and more complex. We see more and more private companies acting in the space field. We see more and more private investment being invested in telecommunication. Yet, we need to be vigilant. We need to be, as multi-organizational, multinational organizations, helping industry to secure those networks, those highways of data, so that governments can also use them. The space segment, starting from the top, unauthorized access, data corruption, manipulation of the data. In space, RF jamming, spoofing. You know very well with your dear neighbors what jamming means. Denial of service, malware injection, and unfortunately, anti-satellite weapons. And I say unfortunately because in space, we don't have the same laws of physics, as you probably know. So if a satellite is being destroyed, you're creating thousands, if not millions, of debris that will take a very long time to decay and come back. So we need to look at the threats in a holistic way from the space segment perspective. But there's also a user perspective to it, with spoofing, man in the middle, hijacking devices. You've read things in the news. Data theft, but also on the ground segment, so where you're operating the network, where you're operating the satellite. So in technical terms, we call it the NOC, Network Operating Center, or the SOC, Satellite Operating Center, where you could have malware attacks, supply chain, and worst, which we have not yet seen, system hijacking and control takeover. So we promote a proactive threat defense. We have a concept which is called Space Shield, where we mapped 100 adversary tactics and techniques for the space segment alone, and we published it. This is concrete. This is an example of a proactive approach that we're taking with ESA. But as we said, the threat domain is evolving rapidly, and you permanently need to update. There are cyber attacks that took place, which are real, and unfortunately increasingly frequent. So our colleagues from JAXA, the Japanese Space Agency, where attackers gained unauthorized access to some of their system. The impact was the theft of national security information. KSAT, where we had a cyber attack on the Viasat satellite at the moment of the invasion of Russia and Ukraine, which basically disrupted communication services across Ukraine and Europe. Starlink was also targeted by Russia, where the military communication and internet connectivity for civilian use was disrupted. And then you had the Russian satellite attack, kinetic attack, where Russia destroyed one of its own satellites, yet created a pollution of debris in orbit that will take years to decay. So the geopolitical landscape is evolving, unfortunately, rapidly and in a more and more challenging way. And what we are seeing is that even if you think about space as a commercial endeavor, the military world is not too far away, and the threats that we're seeing from the military are in fact materializing also on the commercial side. So the emerging trends, technologies, challenges. On the trend side, I mentioned space is becoming more and more a commercial domain. We see actors investing. We will see in the very near future some announcements, I hope, on IRI2, demonstrating a true public-private partnership with massive investment from the private sector, alongside the investment on the governmental side. And this is demonstrating a trend which is there to last. Not everything in space is going to be commercial, but there is a commercial endeavor. Some will fail, some will succeed massively. When you look at the US Starlink success, this is a private investment which has now reached more than the sum of the traditional operators. So quite significant. We are growing more and more reliant on space technologies. I took Uber to come here this morning. Without GPS, without Galileo, these systems, these applications would not exist. And we are looking more and more into geopolitical tensions. I think being in Estonia, it's relatively clear, but this is global. And these tensions can be linked or correlated with also things that are happening, such as natural disasters, climate change, and these tensions will multiply in many areas of the world. So the communication element is not just a local element, it's a global one. In terms of technology, what we're seeing is with the multiplication of assets in orbit, space situation awareness is key. Knowing what is happening in space, looking at probabilities of collision, making maneuvers to avoid those collisions, but also the world of quantum. This is the avenue for the biggest disruption. Quantum communication linked on quantum computing is a revolution. Yet, we are testing the limits of physics on the ground, because the principle of quantum is the exchange of photons that cannot be changed, otherwise you alter the state of the photon and therefore you alter the communication. So the whole purpose of quantum communication is to have an inherently secured communication, because you know that there was no man in the loop or in the middle, but on the ground the light does not travel as far as it does in space. So the space element is going to be a key element for quantum communication in the future, and therefore for quantum encryption, so that all the communications which we think are secure today may not be tomorrow if you're able to just break the code with brute force. And of course, artificial intelligence. We're going to see more and more artificial intelligence in loop. We're going to see artificial intelligence in space, as close as possible to the sensor. And in fact, when you look at the trend of data being produced from space, it's growing exponentially to the point that the RF networks are going to be either saturated, or we're going to have to look at optical communication to bring down the massive amount of data back to the ground, or we're going to have to select the information that is worth bringing to the ground, and therefore looking at AI system on board. This is inherently dual use, so you're going to have the same for defense systems. In terms of challenges, one of the biggest issues is the question of standardization, defining a norm, and having this norm adopted across the board. And I tend to think that the norms are defined by volume. When you look at optical intersatellite links, there was a debate for a while between a European standard, a US standard, to be able to exchange with this laser link. Given the amount of optical heads that the US has ordered for their SDA programs, this has become de facto the standard. So we should be cautious in defining European standards that are not going to be adopted, because in Europe, unfortunately, the market is relatively small. And what we want is to make sure that our industry, as ESA, we are here to promote European industry, so that our industry is able to compete globally and not limited to a niche market in Europe. The security of ground station is going to be key. And I was talking to some colleagues earlier before the start of the conference. We tend to think space with satellites. But space is a whole system, end to end. It starts on the ground, goes to space, comes back to the ground with a user. And space is not just the shiny satellites that go on a shiny rocket and that is launched. Space is an end-to-end system where there is quite some activities to be done on the ground. And I encourage industry to not only look at what will go in space. It's important, it's maybe the visible part of the iceberg, but think about the ground, the security that goes to the ground, think about the user, and not only the ground station for the network access. And then we have a realization in Europe that we are actually technologically dependent, that we are technologically sometimes depending on legacy systems. And here the challenge we have is to promote, as the public sector, the innovation and to promote the Europeanization of elements that we don't have in Europe, so that we are independent and sovereign in our choices. So the main objective is really to protect our member states. We have 22, soon to be 23. We need to make sure that the investment, so the taxpayers' money that is invested in space, bring a return, but we also need to develop and secure the space system. So it's both securing as much as possible an economical development with a return on investment, as much as securing the capability and the sovereignty of the communication itself. So this is maybe very high level, but could trigger further discussions. Our security principle, first and foremost, is secure by design. You need to integrate security from the beginning in your design. If you have a system that will be accredited, you need to think about accreditation from day one. You cannot think about accreditation as an afterthought. Cryptographic protection, very important. But of course, defense in depth. So no single security measure is completely foolproof. And this is why we are promoting layering defenses to provide redundancy. So our security approach is starting with agreements across governments, across member states, regulations, policies. Then we have the engineering element, and the third pillar, which is essential, and for which we are working with the European Commission, USPA, I think Rodrigo is coming this afternoon, is to talk about security certification and accreditation. So we are launching agreement with state parties, and you're probably familiar with NSAs, National Security Agencies, to look at the protection and the exchange of classified information. But we need to be ready to enhance connectivity and secured communication. So talked about quantum, but now I'm going to talk also about spectrum sustainability in the frame of a governmental connectivity. With the multiplication of assets in orbit, with the exponential growth of satellites operating in an RF networking, what we see is the traditional ITU, which is regulating frequency rights across the world from the United Nations, gave priority to the GEO satellites, and all the others had to prove that they were not interfering with the GEO satellites. But when we have state actors, such as China, when we have private actors, like we have in the US with Starlink, with tomorrow Amazon Kuiper, or even the SDA with the DoD program, we see a multiplication of assets, we see the multiplication of potential interferences. And the interferences will be at two levels, maybe three. The first one, gateways, access to the network. If you have interferences here, the entire communication system is going to be disrupted. Then the user, if you have interferences, the quality of the communication you're paying for is not going to be there. Therefore, you're going to ask yourself, why should I pay for that service? So it's endangering the business model of our operators. And then the third, the maybe, is we may see more and more interferences in orbit. And what I'm talking about here is the commercial side. Then there is the defense element, which is probably more of a voluntary disruption than a disruption that would just happen by the sheer numbers. So spectrum sustainability, monitoring interferences, being able to geolocate those interferences, being able to attribute those interferences will be important for the regulators, not ESA per se, but the regulators, national level or European level or at the ITU level, to provide what they call in the US Cs and DCs type of instructions to the one who is disrupting the signal. And this is really important to let our European operators thrive and therefore let the entire ecosystem, the entire supply chain thrive in Europe. Of course, this can be more global, and what we should look at is Europe and its presence throughout the world. It's not just the European continent, and our ability to serve the citizens of Europe. In terms of quantum communication, we are active today in quantum key distribution. It's a technological development. We are running several demonstrations in orbit in parallel. And what we're trying to launch in parallel with the Commission is what we call EuroQCI, which will be potentially integrated into IRIS² in a second generation. And this is, from the beginning, taking into account the possibility to have an accredited, secured system. And what we are trying to do is to convince the NSAs, who are by definition cautious, which is normal, that's their job, that this new technology is actually feasible. And why is it a problem? Because despite what you think, laser communication can be disrupted by winds in the upper atmosphere, by dust, by sand, and water reflection. And laser communication does not travel very well, as you know, clouds. So we have a lot of convincing to do with the regulation part, but this is a promising area of development. And what we do is we go into a ramp-up approach, starting with a concept called Eagle 1, which is not accredited, but which could be used for securing banking across the globe. Then we'll move into a program called Saga, which is moving forward. We are towards the end of the phase B1, where we're looking at the protection of critical security technologies and we are integrating the security proof from the beginning. And then this will evolve into the accreditation, EU confidential, EU secret, to then the full deployment on IRI Square with a fully accredited system. QKDSat is one example. It's a program that we have in the UK, where we are working with an operator to distribute keys to European actors. It's a parallel program to Eagle One. Technology demonstration is key. The European Space Agency is an agency promoting research and development. And what we want to look at is really the end-to-end demonstration. So space, ground, and user terminal. IRI Square, I talked about it a little bit at the beginning. This is a flagship program the European Commission is launching. We are partnering with the European Commission. We have a partnership project that we're launching together with the Commission in parallel. And then we have entrusted tasks that the Commission has given us to look at the qualification of the system from the beginning, from the design to the verification in orbit. And we will also look at the next generations. We will work with the Commission on the multi-orbit approach. There will be MEO, so medium Earth orbit, LEO, what we call LEO-I, around 1,000 or 1,200 kilometers, and then the LEO-Low, where we're trying to develop an ecosystem of SMEs and startups for additional missions, and this will be complemented over time. This is a program where we, together with the Commission, decided to have up to 30% of SMEs, small and medium enterprise, and what we call mid-caps. So the IRI Square program is open to the EU 27 members. Estonia is fully capable of providing competencies to the system. And we can discuss afterwards how you can get in touch with the consortium that is currently bidding for this. But I think that you have key competencies in cyber which could be of interest. Then projecting ourselves in the future, Gen 1 consolidation. We imagine that we are signing the contract, launching. How do we work on the technology, the radio access network, optical terminal, and interoperability? The Gen 2 expansion, enhancement, improvement, or maybe new functionalities, new services. User terminal. The constellation is as good as its adoption by users. What we're looking at is multi-orbit user terminals. But from a commercial perspective, there might be a specialization of user terminal for LEO or user terminal for MEO. And then finally, light gov and commercial. Here we're looking at hosted payloads developed under the program ARTES 4S, which is a program we have at ESA to work in partnership with industry and promote those missions that could be beneficial for the governments, but run by commercial actors. And I give you two examples, air traffic management or maritime surveillance and maritime communication. We are creating a program, or we created in 2022 a program called Civil Security from Space, where we are looking at basically 3 levels. First one is a national level, focusing on national specific needs, assets, that will be interconnected to other national assets in different countries through a network which we call Serenity, that will allow the participating states to have international relationships, gov to gov, to potentially have a containerized version and help a country that is facing a natural disaster. The key here is we are not launching satellites on the telecommunication aspect. We are looking at the orchestration, the piece in the middle of the entire puzzle. What we're looking at is AI and security of the overall system. We're looking at standardized API, standardized interfaces to plug assets available at a national level and in the concept of pooling and sharing with the other participating states. So we are seeing this as a complementary activity to IRIS². IRIS² could bring basically the pipe for communication, and we would bring in the additional functionalities with having in mind the user. The user is the fire department, the policemen, the blue forces, and how to make sure the data that those users need is delivered to those users as well when the terrestrial networks are done. A few years ago, we had major flooding in Germany. People were sitting on their roof. They had cell phones, fully charged, but they were unable to communicate. The terrestrial networks were done. How can we help first responders communicate when the terrestrial networks are done? This is the target of this program. Spectrum sustainability, I mentioned it previously, but what we are looking at is really the optimization of the spectrum usage. When we talk about 5G networks, when we talk about 6G networks tomorrow, we are talking about a multiplication of devices that could connect to those networks, and we need to optimize the spectrum usage, but we also need to make sure that we limit interferences. And therefore, what we're looking at is federating partners at national and international level. We're looking at the governance. We're not a regulatory body, I mentioned earlier, but what we would like to do is to provide a system to a regulatory body that would be able to act and preserve the rights of operators to deliver a service of quality to users. And then we need to validate the technologies with some demonstrations. So there are synergies between what we do at ESA and what industry and academia are doing on their side. And we have, through the 4S, so the program developed at ESA to work in partnership with industry, work plans where we focus on resilience, robustness, security. We have today 17 new activities that have been approved in 24. We had 12 new ITTs that were published in 23. We have spinned off a lot of these activities together with the Commission. In fact, IRIS² was born under 4S. And because of the magnitude of the investment, this was then discussed with the Commission, and the program was born. GovSatcom, we have entrusted tasks from the Commission. We're looking at the procurement process, documentation. We have 8 ITTs that have been issued. We have new actions which are launched to promote EuroQCI security baseline. Cybersecurity, ensuring that the cyber-secure SATCOM, the technology, the product, the tools, the facilities, and the protocols are in place. There is an Estonian initiative called the Space Cyber Range that we worked together with ESA. And they are work packages, activities, and calls for proposal. So this is really also interesting to work together with the Estonian government to propose activities that we can embark based on those programs. And then, of course, we're looking at the next generation of secured SATCOM systems with new spin-offs. And I mentioned air traffic management. This is really a key area. The European airspace is highly congested. I don't know how often you fly, but the number of times your flight is delayed or your flight is simply cancelled is growing, simply because in Europe the airspace is highly congested. And for those countries who are currently at the border of Russia, On top, we see jamming happening, so which is not making life of the air traffic controllers easier. And then there are further synergies in terms of collaboration with national agency. For example, in Spain, we are working with CDTI, and we worked on their SpainSat national satellite, in particular with the development of the active antenna. We see a crucial role of industry in building secured communications, but what we see is really that we don't know everything. You industry, you academia are in touch with your own national needs, with your own market, and if you have good ideas, you can come to us, and we'll try to see how to scale some of those ideas, provided that there is an interest from your government to support. So as a conclusion, you have this nice picture of a Roman road. Resilient communication has always played a key role in the human society. The present geopolitical context highlights vulnerabilities of our communication system. You may see it as opportunities for advancing technology, advancing business. And the secured communication systems are needed to add resilience to the sovereignty of European communication. Sovereignty is going to be a word that you're going to start to hear more and more in the coming years. We cannot be dependent on other nations. We cannot be dependent on commercial systems that can simply, at a turn of a switch, switched off. Thank you.
Thank you very much, Laurent, for a wonderful keynote. I believe you answered all questions because the audience doesn't seem to have any, or at least I don't see any from our Mentimeter environment. Dear friends, you have roughly 10 seconds to post your question to Menti, so I can ask it from Laurent. Otherwise, you'll have to wait until the coffee break to have a discussion with him. Now, let me see. 5 seconds remaining. No questions arriving. I guess you covered it all. Thank you so much. But I do hope that you will stick around. So people, if they forgot to ask something now, maybe they can come up with a question later.
I like coffee, so I'll see you there.
Thank you very much.
Thank you.
Excellent.